Okay, so we're starting absolute value. Back in the beginning of the school year, we learned that the absolute value function, noted by the bars, the absolute value bars, is the cute little v. Why? Because if you make a table and you pick x's, when you plug in each of those numbers to figure out what y is, the absolute value is always going to give you the positive version of that number. The absolute value of negative 2 is positive 2. Remember, absolute value is the distance in numbers away from 0. It's 2 units away from 0, so the absolute value of negative 2 is 2. The absolute value of negative 1 is positive 1. The absolute value of 0 is 0 because it's already at 0. There's no distance away. Absolute value of 1 is 1, and the absolute value of 2 is 2. So I'm going to wait for that. If you graph that, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2, we see that we have the V form. That's the parent. That should not be a surprise. So where do all the other numbers come from? Well, because we remember transformations, there are 3 things happening to this first graph. You should recognize right 1. You should recognize a reflection over the x-axis, and you should recognize down 1. If the parent function is here, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2, if this is the parent function, and we take each of those points and we literally go, right 1, reflected, that's not going to move, and then down 1, right 1, reflected, and then down 1, right 1, reflected, and then down 1, you can easily see the new function, the new graph. Now, you can take each of those points and you can do that, and that's fine. You can do it in a 3-step process. Shift everything right 1, everything reflected, and then everything down 1. If you really wanted to, you could even show me a bunch of different graphs. You could show me each of them in stages, every point right 1. So there's that. And then you could do every point reflected. So if I reflect over the x, reflect over the x, that's the purple. And then you could see that I ended up with the pink because I shifted everything down 1. You can do that, but that looks really, really messy, and that's okay. But still, there's a better way. There's an easier way, in my opinion. Now, what you can do instead is recognize that absolute value is actually 2 pieces of lines. Here's one line connected with another line. So here's what's really cool. Your stretch, shrink, or reflection, because these are 2 linear graphs pieced together. Do you remember piecewise? A piecewise function where you'd have the 2 different equations or more, and then you'd have what x could be, greater than or equal to, or less than or equal to, or whatever. Well, that's really what's happening here. You've got a line and a line pieced together looking like this. So it's totally fine to write them as a piecewise. It's totally possible, and you may, hint, hint, have to do that on your test. However, you also can recognize it's really easy to graph by simply using the stretch, shrink, or reflection as your slope. So if I'm taking the parent, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So here's the parent. and I'm going to go left 1, reflect again over x, and then move up 3. All I really need is this starting point and how it's shifting. If I go left 1 and up 3, here's my new starting point. Now, I could totally do left 1, reflect over x, and then up 3. But what I want you to recognize is because this is linear, because absolute value is 2 lines pieced together, that is your slope. So the slope of those 2 lines is -1, as in -1 over 1. As in, once you know that you need to go left 1 and up 3, and there's your new starting point, use your slope. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Now that's only one side. You'll have to know to go back the other way. Down 1 and back 1, down 1 and back 1, etc. But that's not hard. That's actually really, really easy. So telling me about stretches and shrinks and reflections should be really, really simple because it's just your slope. So how do we go? We go right 2, down 3. This is positive, so there's no, that's a terrible plus sign. So there's no stretch, shrink, or reflection. Right 2, down 3 is your new starting point. And then our slope is +1 because there's no reflection, stretch, or shrink. Now I'm starting to notice, so this is just left 1. The parent left 1, and then everything else stays the same. The thing that I'm not liking is that I'm realizing that I don't think any of these examples, they don't. None of them have any different numbers, like 2/3. That's just a 2/3 slope. It's a shrink by 2/3, but it really, because they're linear, it's just a slope. So this is going to be a slope of -1. This is going to be left 4 and up 2. Left 4, up 2, a slope of -1. Okay. Left 3, up 3, reflect, aka -1 for slope. Left 3, up 3. My new starting point, down 1 over 1 in both directions. Absolute value V. Right 3, down 5. No reflection. So up 1 over 1. +1 slope. Left 4, up 2. No reflection. Left 4, up 2. So up 1 over 1 in both directions. Writing the equations just as easy. Look for your slope and look for your starting point. You know the equation is going to have the absolute value with an x inside of it. So when you look at the parent function's starting point at the origin, clearly we've gone 1, 2, 3 to the left, which means you're going to have an x plus 3 inside. Remember, inside with the x is the opposite of your instincts. We've also gone up 1, 2, 3, 4. So that would be on the outside of the bars, and that's the up 4. Now this is when it really pays to understand that your reflection, stretch, or shrink is just the slope. So this is negative because it's going downward. It's down like a frown. It's been reflected. Down like a frown means it's negative. And this slope is clearly down one, right one, down one, right one, down one, right one, down one, right one. So the slope is negative 1 over 1, which is taken care of by that negative right there. This is all that you need for that example. If that were anything else, you'd put that number right here. Let me give you an example. If this were a graph that we were doing, so here's an absolute value v. For this equation, for this graph, from the origin, we've gone right to down 1. So down 1 on the outside, right to opposite of our instincts inside with the x. Now the slope is clearly negative because it's opening downward. And if you look at the actual slope itself, it's 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Rise over run is 3 halves. So the slope, the stretch in this case, the vertical stretch would be by the negative 3 halves. The negative is the reflection, and the 3 halves is what it's stretching by. So that was an extra example. Okay, so the actual equation for this graph, I'm sure by now you figured it out. Its slope is down 1, right 1. So we're going to have a negative in front of the bars. Inside the bars, we will have to the right 2 to get to that new starting point, that new anchor point, which would be a minus 2. And then we went up 1, 2, 3, 4, plus 4. No reflection this time. Just 1, 2, 3, and then 1, 2, 3, 4. So 3 to the right would be subtracting 3, down 4 would be subtracting 4. No reflection, and notice these slopes are all 1 over 1. I should have made this different. 1, 2, 3, 1, 2, 3, 4, 5. Reflected, there isn't one, so it's up like a cup. Right 3 would be minus 3, down 5. And again, that slope is 1 over 1. I should have made them different. I'm so sorry. This is honestly, well, you can see it. It's not mine. I should have recreated it, but I was in a hurry. You know, lots of things going on in my life right now. Okay. No shift left or right. So it's just the absolute value by itself inside with the x. I said that weird, but I mean x is inside by itself. And it's up 2, so that's on the outside. Vertical shift up 2. Again, the slopes are all 1 over 1. So, and it's upward like a cup, up like a cup, so then there's no reflection. Looks like we went right 1, down 1. So right 1, down 1. And no reflection, and slope is still yet again 1 over 1. And here we go, we went left 1, 1, 2, 3. So left 1 would be plus 1, up 3 would be plus 3 on the outside, and it is reflected, and the slope is still again 1 over 1. So it's just a negative out in front. Right 2, 1, 2, 3, down 3. Right 2 is minus 2, down 3 is minus 3, and again the slope is up 1 over 1, so, and there's no reflection, so it's just positive. Easy piece of cake, hope you did well.